Okay, we are learning about similarity rules, and we know that similar shapes are the same shape but different size. Okay, they're exactly the same shape, and we always talk about triangles in this unit. So we're looking at 4 different pairs here of similar triangles, and you can see very clearly that they are the very same shape, but they are different sizes. All right, so let's look at our similarity rule, and I want you to keep in mind that we are now using a symbol like this to say this triangle is similar to this triangle. Okay, it's a wavy equal sign. Okay, our first rule is very similar to our congruence rules, and it is side, side, side. And what that means is that instead of all the sides being the same this time, all pairs of corresponding sides are in proportion to one another. And that means they have the same scale factor. So if we've multiplied this side by 2 to get this side, then the scale factor between this one and its corresponding side, this one, will also be 2, and the same goes for this one. If you compare all pairs of corresponding sides, you should get the same scale factor each time. Now our next one is angle, angle, angle. And now this one's a new one. We don't have this one in congruency, but what we know is that if this angle is the same size as this angle, and this one is the same size as this one, and this corresponding angle is the same one as this corresponding angle, then what we have is the same triangle but enlarged or shrunk. Okay, so in this case, all angles, all of them, are the same as their corresponding angle. We're always talking about our corresponding side or angle in this case. Okay, it has to be that one it matches up with, just like in congruency. Okay, this one over here, our next rule, very similar again to a congruence rule, and this is a side angle side rule. And this time we're still talking about, say, one side, another side, and the angle in between. But this time the difference is that even though the angle will be the same, so the included angle, remembering that the included angle has to be between those two sides, so the included angle is the same size, that's important, and the corresponding pairs of sides must have the same scale factor. So this is, this is just like this one up here. Now we're talking about scale factors and in proportion. We know that this side and its corresponding pair side, this one, are not going to be the same size, but we know they will be in proportion. So if we multiplied this side by 1.5 to get this side, then this side will be multiplied by 1.5 to get this side. Okay? It's really important that this time we're talking about scale factors. Now our final rule is very similar to another one that we had in congruency, and it's right angle, hypotenuse, side. So these are our right angle triangles this time, and we have a hypotenuse over here across from the right angle, and we can choose any other side as long as it is corresponding to its pair. Right, so same thing this time. The right angle will be the same, right? And it's always going to be the same size anyway. And the hypotenuse and the other pair of corresponding sides will have the same scale factor. Can you see a pattern? So it's really important that if we had, say, this one, in this case we would actually have to divide it by something because our second shape is smaller. If our scale factor was, say, 0.3, so it's a third of this size, then this side would have to be the same as this one, and the hypotenuse is what we're checking. So the hypotenuse, another pair of sides, and the right angle on this. So even though our congruency rules look very similar to these, they are very different. Remembering that when we're talking about similar triangles, we're talking about different sized triangles.